And this month, we are pretty lucky to have Rosalind McCann. She's our USU Extension Specialist, or Sustainability Specialist, that's a mouthful, and Jeff Adams with Terra Sophia LLC joining us tonight, or this afternoon. They have both been heavily involved in changing Utah's gray water policy, which benefits all of us. So I'm really excited for this webinar, and with that, I will turn the time over to them.
All right, thanks, Candace. Hi, everyone. So as mentioned, I'm Rosalind Brain McCann, and I'm based out of the USU Moab Regional Campus in the Department of Environment and Society. And you can learn more about the work I do in environmental sustainability by visiting extension.usu.edu/sustainability. And I think Candace will put that link for my website up in the chat for you all. So just thinking about gray water, after attending a water harvesting practitioner certification course in Albuquerque, New Mexico in 2014, where my co-presenter Jeff was actually one of the teachers, I returned to Utah excited to install a gray water system. My husband and I were building a straw bale home, and the timing seemed perfect for me to be thinking through that process. After reviewing the policy, however, I was discouraged and frustrated by the number of unnecessary complications for a small-scale residence, including the requirement at that time of a tank and a pump and other complications to the system. So Jeff, who now lives in Moab as well, our local health inspector, and I worked to revise the state policy to allow for gravity-fed systems, which you'll learn more about in our presentation today. So fast forwarding a couple of years forward, in July of 2016, I did obtain the first on-site gray water permit for a residence in Utah as part of a pilot program. And this image that you see on the cover of our presentation is of a gray water basin at my house, which Jeff actually worked to install the earthworks for. And the plants have just really thrived in that system. And you'll see in this picture here is echinacea, lavender, volunteer sunflowers, a peach tree, Russian sage, blue flax, borage, globe amaranth, and much more that are thriving on simply water from our residents after we take a shower or use our laundry. And so Jeff, go ahead and introduce yourself as well.
Yeah, thanks everybody for coming out. My name is Jeff Adams. I'm the owner and proprietor of Terra Sophia, which is a permaculture design consulting and landscape contracting firm based here in Moab. And I guess I've been on the gray water path for quite a while. I first got exposed to gray water while a college student at Humboldt State University in Arcata, California, where we had a couple different versions of experimental gray water systems going on back in the early 2000s, prior to some of the revised code that came a little bit later in California, making it even easier there to do some of these systems too. And then I've been off and on involved in various gray water trainings, taking trainings with Gray Water Action, a great group out of the Bay Area of California that has a lot of good resources, as well as Watershed Management Group down in Tucson, Arizona, which is another great resource for training and some publications they have on their website. And just really was thought that most of the Western states were kind of on board with these gravity-fed landscape direct gray water systems until I got to Utah. And then, like Roz said, it was just kind of all of a sudden reading through the code was like, wait a minute, you have to put this in tanks and use pumps and filters, even for like a simple residential home. Like, I understand some of the bigger commercial sites that have higher volumes and need to work through that might need some of that mechanization and surge capacity, but it seemed a little overkill for the average residential application. And so working with Roz and Orion Rogers of the Southeast Utah Health Department, over the last 4 or 5 years, we've done a series of technical presentations at different conferences, working back and forth with the various state level committees that are overseeing on-site wastewater systems and some of the code revision process, and then was able to help Roz and her husband design and build their first permitted system, as well as for another residence in Moab, designed and built the second permitted system. And now that the new code is in place, it's really opened up a lot more opportunities for people throughout the state of Utah to adopt some of these low-tech solutions to reuse this valuable resource.
Great, thanks, Jeff. So I'll begin the presentation today and then we'll pass it over to Jeff halfway through, but I'll be around the entire time, obviously, for questions towards the end. So Jeff and I have one major goal for this presentation, and that is for you to learn how to use secondary water as a form of landscape irrigation in Utah. And so this picture is from one of the basins at my home, as Jeff mentioned, the design and install of those systems. And you can see there various parts that we'll learn about some more in the presentation today. And then with that goal, by the time you walk away from our presentation, even though it's only going to be about 30 minutes with us, we are hoping that you'll be able to understand the basics of Utah's gray water policy and observe system examples, and lastly, develop basic skills in implementing your system as well as you look towards designing your own home from scratch or potentially retrofitting. Okay, so as was warned, I have a question for you all. If you could put your answer in the chat, that would be wonderful. So as we begin thinking about water reuse potential, I'm curious what fixture in the home you think the largest user of water on average may be. If you've already answered, it's okay, but for those of you who haven't, I am discounting toilets in your answer. So any fixture besides toilets that you think is the largest user of water in the home. And yes, please reply in the chat and Candace will get the answer to me in a few minutes when I request that. Okay, so keep thinking on that, keep replying in the chat, and I'll move forward with the presentation. You can keep replying on as I'm in future slides. We have a few minutes for this. So let's begin with some definitions to ensure we're all on the same page when it comes to what gray water is, but also some other terms that are associated sometimes as you're talking about gray water or water harvesting systems. So first is gray water, and you might think, gosh, I see this spelled so many different ways. It all means the same thing. It's just, it depends where you're at, how it's spelled. So various states spell gray water differently. So gray water with an A, all connected, gray water with a space between gray and water with an A, and gray water with an E, or gray water also with an E with a space between gray and water, is all referring to the same thing, gray water systems. And so the Utah Office of Administrative Rules defines gray water as wastewater from bathtubs, showers, bathroom wash basins, clothes washing machines, or laundry tubs. Gray water does not include wastewater from toilets, kitchen sinks in the state of Utah, photo lab sinks, dishwashers, water softeners, garage floor drains, or other sources that might pose a public health hazard. So that is the definition of gray water, just as you think about what gray water is, especially in our state of Utah. Clear water is another term that you might hear thrown around, especially when talking about gray water systems. Clear water includes water produced while waiting for your faucet to heat up. That's a common example. So you might put a pot underneath your tap, which we do constantly at our home in Moab, as that water is heating up to wash the dishes, and then we pour that pot over plants in the backyard or within our house. So that's an example of clear water. It could also include refrigerator compressor drip, swamp cooler, and air conditioning sweat. So those are examples of what clear water is. It's treated water that is from a direct source that hasn't been used in the household otherwise. Black water is another term, and black water includes your toilet water, but in Utah, kitchen sink and dishwasher water are also categorized as black water. And this is due to increased likelihood of E. coli presence. And so black water is not part of your gray water system. That still goes to sewer. And toilet is the most common thing people associate with black water. And there's other terms as well that come up constantly as you think about, or frequently as you think about water harvesting. One is stormwater. And so stormwater is, the EPA defines it as rainwater or melted snow that runs off streets, lawns, or other sites. As stated by the Utah Department of Environmental Quality, stormwater runoff from homes, city streets, parking lots, industrial facilities, and construction sites often contains sediment, fertilizer, pesticides, oil, gasoline, pet waste, or hazardous waste. So this is actually a plug that I didn't expect to put in here, but to really think about harvesting rainwater effectively through earthworks at your house to reduce the contribution to stormwater runoff, which is a stress to our environment. locally and across the globe if we look at this at a large scale. Because stormwater isn't treated, that runoff you see flowing into the storm drains is discharged directly into nearby water bodies along with any pollutants it contains. So that's from the state of Utah about what happens with the stormwater runoff on our streets. And then lastly, for term definitions is, of course, rainwater. Rainwater is defined as water falling as rain that has not collected soluble matter from the soil and is therefore soft. That's the definition from Merriam-Webster Dictionary. And so it's rainwater falling from the sky, and you can capture that in tank systems, or it flows off your property and then becomes stormwater as it picks up contaminants along the way. And now that we're clear on our terms, you may be wondering, why gray water? So let's set the premise of this thought with a quote. And I'll give you a minute to read that. So gray water is one way to achieve higher resource abundance in light of forecasted hotter, drier weather in the Southwest, where we also happen to have some of the highest per capita residential water use as a result of high landscape irrigation rates. And by rates, I don't mean costs, I mean applications. So we're using a lot of water, but we're also in one of the hottest and driest areas of the US. And according to the Utah Geological Survey, irrigation accounts for around 72% of Utah's water use, and 50 to 60% of average residential indoor water use could become potential gray water sources. And advantages of gray water include effective water treatment. And so this occurs through treating the water in the uppermost biologically active region of the soil where it's discharged, and reduced use of ground and surface water resources for landscape irrigation. Another benefit is reduced use of energy and chemicals for water and wastewater treatment, and also improved plant growth. So that has been shown through research in other states. Other benefits include reclamation of nutrients. So also, wastewater disposal in rivers and oceans is a significant form of pollution. So like I mentioned before, if you're actually discharging more into your own landscaping, slowing, spreading, and sinking that water on your own property, then you are helping reduce the stress on the system as a whole and reclaiming some of those nutrients in your own landscape. Two more benefits include, first, an increased awareness of natural cycles and personal water use, which is really neat just to see, as I take a shower, the effects that's having on my landscape, and what that would mean if that was actually going to a sewage treatment plant, and being more conscious of your water consumption in general because you're more involved in the system on your property. And lastly, a landscape irrigation source in preparation of potential future drought irrigation restrictions. And I say that just as we look at hotter weather ahead and the potential for increased rates, which actually the city of Moab is currently discussing. So let's think about what quantities could be captured in a gray water system. I mentioned a statistic before, but if we think about the individual fixtures in our home, I'm curious what most participants on this webinar guessed had the highest water use of those fixtures. So Candice, which one was it?
It was a really close tie between shower heads and the washing machine.
Oh, good.
Shower
Okay.
head, bath.
Shower head and bath?
Bath, yeah.
Oh, so those two, not washing machines.
No, sorry, I'm not being very clear. So the shower head bath was kind of combined into one.
Okay.
That was very close to washing machine. Washing machine was second.
Okay, so pretty smart group on this call. By combining shower and bath, it is the highest water use in the home outside of toilets. So if we look at this slide, this is from the Water Research Foundation. It shows various fixtures in the household and the average water use across the US. And so here, the toilet is 24%, but if we combine the shower and the bath together, that's actually 23% of our indoor use, or 31.3 gallons per household per day. And so those of you who guessed that were correct. Congrats on that. But the clothes washer is also a large contributor. And if we combine that with the shower and the bath all together, we see at least 39% of our indoor water use could be captured in a gray water system, and that's 53.3 gallons on average per household per day. That's discounting faucet. The reason I discounted faucet from this study is that they combine faucet altogether. So that would include kitchen sink, but also bathroom sink. And in Utah, we do not connect with the kitchen sink for our gray water systems. So congrats to all of you who guessed that right. And I'm going to pass it over to Jeff to take it from here.
Great, thanks, Roz. So I'm not going to go through the entire gray water code. I'm going to hit on a couple updated pieces of this revised code, and then I'm going to really start to look at some of the code requirements and sizing for all systems, but with a special attention to the newly allowed gravity-fed distribution system, also known as the branch drain system. So one of the couple, I'd say there's like these three major things that I feel came out of this new code revision. One is that it separated gray water systems into tier 1 and tier 2. So that really was inspired by some of the code that states like California and Arizona have, where they're really trying to match administrative oversight to potential risk. So in the state of Utah's new code, a tier 1 is a residential system using gravity. So just really the simplest of systems. And those tier 1 systems require an on-site wastewater professional that's certified in level 2 to design those. And so in the Utah on-site wastewater treatment system, level 1 is to do soil texture analysis and percolation tests. Level 2 is to design conventional systems, and level 3 is to design alternative systems or some of the advanced on-site wastewater treatment systems. And so some of that falls into the tier 2 systems are going to be anything that's not a single family or multi-family like residential unit. So any apartment complex, any commercial building, anything like that that wants to go through the Utah Gray Water Code would require a tier 2 system and a wastewater level 3 professional. So I think that's nice because it separates out the simpler systems have simpler requirements. And then as you get higher flow volumes or more complicating factors in some of these more advanced systems, that requires some additional consideration. And what we worked hard for and really instigated this code change process was to get these gravity-based systems into the code, because they're in the code in a lot of other Western states, and they've been shown to be very effective, and they don't require a lot of mechanical parts. There's really the only moving part is what's called a 3-way valve, and I'll show you one of those here in a few slides. So we're really happy to have this opportunity to use these branch drain systems here in Utah. And then another nice thing is that the new code allows you to size your gray water system by fixture or by the entire house. And so the previous code used to say you have 3 bedrooms, you need to plan on a distribution system for this many gallons per day. And the new code says, well, if you're only doing the laundry machine, you only have to size it for the laundry machine. So again, it just gives us a lot more flexibility, especially for retrofits where some of the, it may not be possible to do a whole house retrofit, but you might be able to capture the laundry machine or a bathroom or something like that, a shower. So, all right, Nick. So when we're designing our gray water systems, I break it into kind of 2 realms. There's one, how we have to design it to meet the code. And then there's the second part is the site context. And that's how we integrate it into our specific needs on site. And so for these code requirements, there's a table of setbacks that says your discharge area needs to be a certain feet from your building foundation, from the property line, from any wells, culinary lines, creeks, drainages, just these different things that make it so that we're not unintentionally discharging our gray water too close to a water body or somewhere that it might cause an adverse impact. And then as we get into sizing the discharge area. So that is the square footage that you need to be able to put that gray water out on so that it can effectively infiltrate and be treated by your local soils. And that is based on soil texture, and that's where you look at the different relative amounts of clay, sand, and silt, as well as the soil structure. And the soil structure is whether it's a sand is going to oftentimes be very granular. There's also, as your soil texture develops and roots and life get in the soil, you start getting a blocky or crumbly structure. And so depending on your soil texture and your soil structure, you'll be required to have a certain discharge area, essentially gallons per square foot per day. And that's still going to then be based on number of potential bedrooms and the fixtures. And the number of potential bedrooms is the maximum bedrooms that your house could have. And the thinking there is that if you have an unfinished basement and eventually you could develop it into a bedroom, that you want to account for that potential occupancy in the sizing of your gray water system. And it's the same as for on-site wastewater systems, septic systems as well. Though that part of the code is consistent. And then with the soil texture and structure and number of bedrooms in mind, then they've assigned certain standard gallons per day per person to each of the fixtures. So you kind of multiply all those together and you get your target square footage. And that's the maximum, or really, I guess that's the minimum discharge area that you need, but is often possibly more water than a site is actually using. So I'll circle back in a minute to some considerations to size your system as well on what your plants actually need. And then there's some specifications and some tables that essentially say you need a way to divert the water either to your landscape branch drain system or any on-site gray water system. And then at times you also need to be able to just flip a valve and send it back to your sewer or septic system. So in the winter, your soil's frozen, you need to do a load of diapers or something with bleach, something that may not be safe to discharge out into the landscape. You have to have an easy way to put that into the other approved wastewater treatment system. And then there's some specs for pipe sizing and slope. In general, you're going to use 2-inch pipe up to 4-inch, but in my experience, at least in residential settings, is 2-inch pipe. And then you want to make sure you have at least a 2% slope, which is a 1/4 inch per foot on that pipe, so it can effectively convey not just the water, but any lint or hair or other stuff that might be conveyed in that gray water as well. And then there's some specifications on the number of outlets. So depending on your soil type and your gallons per day, that'll specify that whether you need 2, 4, 6, 8, whatever that number is, of individual discharge points, so that you don't put all of that water in one spot and potentially overload or oversaturate your soils. And then it calls for mulch shields and air gap, and I'll show a picture of that and explain that in a second. And then depth of cover, essentially saying anywhere that you're discharging the gray water, you have to have at least 6 inches of cover over that. And that can be cover of anything, but generally what I've always used is wood chip mulch. And I'll talk a little bit more about that here in a second too. And then within the code, and there's these other best management practices that some of them are very common sense, but they just need to be put out there to make it clear to the system designer as well as the property owner and the system maintenance that this gray water is not intended to have any human contact. It's not allowed to pond up on the surface, run off the property. You're not allowed to put it in a spray, irrigation, any sort of sprinkler that will aerosolize whatever that what's in that gray water. And then as you start to get into your plant selections, it can't come into any contact with edible portions of plants. So you don't want to grow carrots in your gray water system, or even really like lettuce or something that has a fairly close edible portion to soil surface mulch interface. And then it's also really important to think about what you're putting down your drum. A lot of borax or other like salt-based um, components, and then generally you're not wanting to put a bunch of bleach or other like chemically hazard things out there. And the code specifically says that like photo labs and some other things like that are not considered gray water, and you're not allowed to discharge in those into your landscape. And then some of the other best management practices would be to properly size and locate the system. And I talked a little bit about that on the last slide. Labeling pipes, that can be either painting them purple or writing, or you can get a tape to put on them that says, caution, non-potable water, do not drink. And then you have to make sure during your soil texture assessment that you have at least 5 feet of depth to groundwater, so that you can make sure that there's enough soil for that gray water to pass through before it potentially could get into any groundwater systems. So that's kind of the code context of how we're starting to think about these systems. And then I think where the rubber hits the road is, how do we actually integrate a gray water system into our landscape? And so it's really becomes a bigger design picture of looking at, how do you actually use your landscape? What existing features are there? Do you have, where can you find that suitable space to have your discharge area? And then how do you get the water to that space? And so that comes into your elevations and grading. So if you think about it, if you're having a 1/4 inch per foot, every 10 feet, you're dropping 2.5 inches. So the further you go, the deeper down your pipe is going to end up being, which isn't necessarily bad, but it's not necessarily good either. The closer we can keep that pipe to the surface, so that we're just, hitting that 6 inch of cover, but not getting too much deeper, saves on cost of installation, also saves on basin shaping, because you don't have to dig as deep of a hole, and then, play around with stabilizing those side slopes, and keeps that water up closer to the most biologically active parts of the root zone and the soil biome. And then it's kind of going back to Roz's introduction, is really, what are all the water sources? How do we integrate gray water if we're looking to have it be some portion of our landscape water portfolio? How do we also design our landscapes so that we're making best use of any rainwater and stormwater, and any if you have a swamp cooler or an AC unit that's has some bleed out water, how do we start to look at all our different sources of water and match them up to their best use? So I'd say in general, gray water is best for perennial plants, stuff that grows multiple years, and is really great for like woody shrubs, fruit trees, perennial bunch grasses, stuff like that, that's going to really develop a deep, robust root system, and can help go find where some of that water might be moving in the soils and take advantage of that extra nutrient load. Whereas passive rainwater harvesting, just having, say, a rain garden in your landscape, that's also very good for perennial plants, but generally, depending on your climate and your amount of precipitation, generally you're going to want stuff that's a little bit more drought tolerant than, say, a fruit tree, if you're trying to get it to establish just on rainfall alone. And then you get into roof water catchment, and that can be a great supplement to some of your higher water use plants. And then with all of this, at least here in Moab, most landscapes are still going to need some amount of supplemental irrigation, whether that's from a culinary system, a secondary system, an on-site well, especially during the establishment period, those first couple years where the plant's getting its roots under it, so to speak. And so you want to think about all of that. And for me, the hierarchy is, how do I first shape my land to hold the water that naturally falls on it and take advantage of that, build healthy soils, put the right plant in the right place. Then I started looking at, how do I integrate gray water to give me some extra water? How do I integrate a roof catchment tank to give me some extra water? And then lastly is, what is my remaining demand that I can meet with my culinary or secondary water system, depending on the specifics of the site. And that then goes into that plant water needs. And I'm not going to get into the math, but there's ways to calculate the how many square feet of certain high, low, or medium water use vegetation you can support on a certain volume of water. And so if we go from the code context that's saying we're producing this many gallons per day and we need this many square feet of discharge area, we can overlay a calculation of I have this many gallons of water, it can support this many square feet of vegetation, and then we can really fine tune that landscaping to be as close as possible to being able to live off of our available water budget through the gray water system. And so I like to think of it as the anatomy of the branch drain system. You know, what are all the parts, heads to toe? So we start with the source. That could be the laundry machine, the shower, both, all gray water sources within a house. Then you have what's called a three-way valve that I mentioned, and that would be located indoors inside of the dwelling, and that allows you to switch from going out to landscape discharge to going to your septic or sewer. And then from that three-way valve, you have what we call the stub out, and that is the piping that goes from your indoor plumbing of that three-way valve outside of your building envelope and allows the opportunity to then be continued into the landscape. And that portion of it is governed by building code and doing that interior plumbing work in terms of that three-way valve and the stub out. And once it's outside of the building footprint, it turns over to health department jurisdiction and these gray water codes. And so at this point in time, it's legal to stub out your building at, say, time of construction and just put a cap on that gray water and come back to it later in terms of actually doing the final design and turning that system on. And so there have been a lot of homes in Moab that have been built over the last 5 to 7 years in anticipation of someday the code changing that are all stubbed out, and now they're ready to go, and they saved the cost of an expensive retrofit. And what I would say with the stub out is this is a gravity-based system, so there's no standing water in the pipe, so therefore it does not need to be below frost depth. And that is a really key thing, because if you're trying to work with gravity and you're starting at 2 feet, 3 feet below ground elevation, you're going to have a really challenging time meeting that 2% slope and having that water discharged where your plants can get it. And so now that was when we started. There were a lot of these being stubbed out here in Moab at 26 inches or so, and some of those we just deemed it's not worth trying to get them on. So really look at the closer to finished grade that you can come out of the building with your gray water for these gravity-based systems, the better, because then you're just working and you're minimizing your trenching and maximizing how many different areas you can get that to. So then there's various, the 2-inch pipe are bigger, and the various fittings, elbows, tees, stuff like that. And then there's these things called the flow splitters, and I'll have a close-up of them later. And it's essentially, it looks kind of like a T, but it's got a little fin in the middle that helps split that water 50-50. And that'll come a little clearer here in a minute. And then it goes to your discharge area, which in this case is the basin. You have a mulch shield, which these aren't hooked up yet in this picture, but those are those green irrigation boxes. And then this will eventually have mulch and vegetation added. And so now we'll kind of go through the different components. So here's a picture of a three-way valve. Jandy is one common version. There's others, and it's just as it looks. You turn it one way, it goes to the landscape. You turn it the other way, and it goes to your sewer. And so the upper right picture shows a little irrigation valve box built into the floor of the home, so it's easy to just, you're doing a load of laundry and it's pouring rain out, you can just pop that off and turn the valve if you remember. The bottom right is a picture of a switch. It's possible to hook up a solenoid valve, and have it so that you can just flip a switch. And sometimes that's really important for convenience, and depending on, especially for retrofit situations, you might have to locate this three-way valve under a crawl space or somewhere that it's not as easy to access, and some of these automation options might be the way to go there. So then next is the flow splitter. Its function is exactly how it sounds. It splits the flow. So the upper left shows one in action where it's coming in. That's the first split coming out of the house. It hits that flow splitter. It's called a double L, double L E. That L is ELL, and they're set so that they're level, so that that water hits and it hits that fin and it goes pretty much 50-50. And these are, it's nice to have that clean out option there just in case some lint or some hair or something gets stuck on it. I haven't had or heard of big issues with that, but it's kind of the easier to drill a little hole and put a plug in and keep it accessible than it is to try to snake up the system from the bottom to unclog it in the event that something happens. And then from those flow splitters, and most systems will have multiple splitters. So you, first time you split, it goes 50-50. Next time you split, now you're at 25% flow, 25% flow, and you can kind of parse it out that way based on the number of outlets that the code specifies and your unique landscape conditions. That there may be situations where you choose to have more flow splitters than is required in the code. And then the right hand picture shows the purple pipe going out to the mulch shields. And so here's the basin. Just as it sounds, it's a hole. You want to get that the bottom of it pretty level, and if anything, actually sloping gently away from your outlet to really help as that water comes out in that one point. We're really trying to help it spread out, percolate out, move through capillary action out over that whole surface and infiltrate through that surface volume. And the bottom right picture shows those same outlets with then the mulch shields. And so the code specifies that the mulch shield should have a minimum of 5-gallon surge capacity. So that's when you have a tub full of water and you take out the plug and all of a sudden you're draining however many 20-30 gallons out into the landscape all at once, that has the capacity to have a little surge as it comes out faster than it can move into the soil and move through the mulch. And then this next picture is showing that same spot, but when it's all said and done. So that's with the 6 inches of cover, that's all the pipes backfilled. Essentially, you can't even tell that it's there, but if you scratch around in the mulch a little bit, you'll easily be able to find those mulch shields, those outlet boxes, and you can pop the lid off and have a peek and make sure there's no ponding or adverse effects happening. So there's a close-up of the outlet into the mulch shield, and it's really providing two functions. One is that surge volume that I mentioned, but the other is it's got an air gap. So there's, per the code, there's supposed to be at least 6 inches between the pipe and the bottom of the mulch shield. And what that does is not only allows the surge volume, but also protects against roots being able to grow into there and up and into your pipes, because there's not many plant roots that can grow in the air. And so it makes it real easy to look in. You can see if there's roots kind of clogging the sides, the perforations in your mulch shield, but it really gives you some protection against roots being able to get into your actual piping. Whereas if that was just covered in soil or, at ground level with some mulch over it, you'd start to find over a number of years that roots are going to try to go where the water and nutrient is coming from. And so in terms of thinking about planting, so you've got the basin itself, and that is going to be full of your wood chip mulch. So that's going to have that 6-inch gap and then the 6 inches of cover. So generally you're looking at for these branch drain systems, a foot or so of mulch in that basin. So that's not really a place that you're specifically growing plants, but it's a place that you're creating a moist, nutrient-rich sponge that plant roots on your benches and upland portions can grow into and tap into that, or really usually grow under and tap in as it's soaking down through. Your higher water use stuff, or your stuff that with less robust root systems, you put on these benches, and that's really only going to be that, say 9-12 inches above the bottom of the basin, so that once you get a plant in there, those roots are hitting that moist soil pretty quickly. And then some stuff, like some of the trees and some things that might not need quite as much water, you put in what I call the upland, which is still like the perimeter of the basin, but is maybe a foot to 2 feet in elevation above where that water's discharging. So it's going to take those plants a little bit longer to tap their roots into the sponge of the gray water system. And there's that same property. This is Roslins place again, and it's a little bit hard to see, but you can kind of tell there's on the left of the picture that Russian sage would be in like the upland, and then on the right, I can't actually tell. I think that's some lavender and some I know there's some echinacea and the blue flax, like all down on that lower shelf, so that their roots can tap in there a lot more. And then the fruit trees are just loving it, and taking up the space they need and tapped into that resource.
Yeah, and those fruit trees are planted on the bench.
And then from a operations and maintenance side, it is required in the code to provide a operation and maintenance guide with the system, so that the homeowner, and especially if there's a change in homeowners, there's a record and a document of what the system is, some pictures of it, what to expect. But overall, these are fairly low maintenance, but they are not no maintenance. And so some of the common maintenance things are visual inspections, just looking at it, make sure that there's no clogging, make sure that there's not pooling or runoff, make sure there's no odors that you smell. Seasonally, the turning of the three-way diverter as needed, really not just seasonally, but as needed. Maintaining the wood chips. So we've found that generally every couple of years, the wood chips break down, especially if you're walking on them. They can become compacted and not move water as easily, and they actually really become a nice topsoil that it becomes a great way to top dress around some of the fruit trees and other woody shrubs, and then replace some of that wood chip mulch, so that you maintain good infiltration and flow through it. The plant care is just based on your specific plant needs, so that's going to be no different than other landscape plants. And then there may be other stuff per specific systems or health official requirements, and that's part of the code, that there is a clause that the health department can ask for additional things. But in my experience, those are really the main bits of maintenance, and a lot of it is kind of more of a visual kind of inspection on a quarterly, annual basis, and then swapping out that mulch every couple of years, depending on how quick it's decomposing for you.
So great, thanks, Jeff. We just recently, with the updated code, which just was updated in the spring, launched our updated fact sheet to go along with that, and Candace was going to put the link for you all in the chat. And this fact sheet goes over the basics about gray water systems, and you'll see some images from our slides today, but information from the presentation as well. It's a great quick resource as you're looking more into installing potentially in your own home. And so just a quick recap, hopefully through what Jeff and I have talked about today, you'll now understand the basics of Utah's gray water policy, observe system examples, or you will have observed them in the presentation. And lastly, develop basic skills in implementing your own system. And we couldn't get into too many of the details in the time frame about retrofitting and other aspects, but happy to answer any questions if you have them in the chat, or also follow up through email, and this is our contact info.